Consider two people going up the stairs, assuming they're relatively equivalent in mass. The first person, in red, goes the stairs at a regular sedate pace. Every second, they go up 2 steps. The blue person is going much faster. They're doing 5 steps a second. The question ultimately becomes, what's going on here? Why do we care? In both cases, the amount of work that needs to be done is the same. You're increasing the gravitational potential energy of both people by the same amount once they reach the top. The difference here is who's going to be tired and sweaty first. The blue person will get much more tired much more quickly, at which point the question is why. The idea here is the idea of power. Power is the rate at which you do work. In this image, the person who is doing the same amount of work in less time is more powerful. They get tired faster. The equation for power is work divided by time. So doing 100 joules of work in 2 seconds versus doing 100 joules of work in 4 gives you different rates of power. The scientifically accepted unit for this is a watt. You typically see these in light bulbs measuring how much power is used, how much work is done by the light bulb per second typically. Though there is another slightly more common one, especially if you do anything with cars. You're used to horsepower. Horsepower is a historical measurement based on the amount of work done a horse could do in a period of time. A car with 100 horsepower can go from 0 to 60 in 12 seconds, where if you had 4 times the amount of horsepower, 400 horsepower, could do that same amount in a quarter of the time. You see how this works. The amount of work in both these cases going from 0 to 60 is the same, but the power going up means that the time goes down to keep that balance constant. Power at that point is just a measurement of the rate. You can talk about its power rating. A car with greater horsepower is more powerful than a car with less. A person who climbs the stairs in a fewer amount of seconds is more powerful than someone who takes it nice and easy. Because power is work divided by time, we can even go a step further. We know that work is force times distance times the cosine of the angle between them. If you rearrange this a little bit, you can do your force is times your displacement over time. Your displacement over time is just your velocity. Both are perfectly valid ways to calculate the power rating of any object, but typically we will stick to the work via time, but occasionally the other will be useful. So in summary, either work. So let's consider this for a minute. It's just a simple equation. It's just a straightforward calculation. But rarely are we doing the math with it. We tend to care more about the conceptual. Identical brothers, Andrew and Brian, are each climbing a set of stairs. Andrew climbs the stairs in 10 seconds, whereas Brian climbs them in 15. Who did more work? Who's more powerful? Well, in this case, they're doing the same. They're going the same distance. They're adding the same amount of energy. They're going up the same set of stairs. So the amount of work they did is neither. Did more work. It's the same amount. They added the same amount of mechanical energies to the system. But because Andrew did it in 10 seconds versus Brian doing it in 15, we would say Andrew's more powerful because the amount of time you're dividing the work by is a smaller amount. Here's one for you to think about. Jack and Ryan are lifting 100 kilogram weights. Jack does 10 curls in 20 seconds, whereas Ryan does 25 curls in 50 seconds. Who does more work? Who's more powerful? Go ahead, give it a try. Check back when you're done. So let's talk about this. If you're talking about the amount of work, who did more lifts? Who exerted more force over distance? The answer here is Ryan. Ryan did more curls. Now, this is assuming that they want the same distance and they're roughly the same body mass, but in general, the person who does more curls is going to do more work. However, the rate at which they did them is important. Jack does 10 and 20. 10 over 20, rough estimate, gives me a ratio or power rating of a half. Half what it exactly is, we're not entirely sure because we're not sure the distance that they're exerting it over. Whereas Ryan is doing 25 over 50. Again, rough math, 25 over 50 still simplifies to a half. Assuming they're lifting them over the same distance, the power rating is the same for both of them. Anyways, thanks for watching. Have a good one.